Hi, welcome back. Now I'd like to go through an example of an ATAM review with you, just so you get some idea of what kind of thing this review is intended to look at and how you'd actually examine it. Now this refers to a case study called the plug-in architecture for mobile devices, the PAM-D architecture. Now, this is a readily available case study. If you go on Google PAM-D, you'll find it. This architecture, the case study is a few years old, as these case studies tend to be, and it was designed at the time when Palm Pilots were the preferred method, preferred portable device. Now they've since been replaced by smartphones, but the principle still holds. We have a device with an architecture, we have plugins, and the intention was that the plugins be common across several different devices. So we wanted this particular plugin architecture to work and support all these different plugins. So the specification for the application of interchange of data and control, it was common across the different PAM-D aware devices, and the whole idea was to develop a plug-in architecture. Now the context, customers and users, this was not flexible. Right? The customer had a vision and a specified product approach. So it wasn't as if the PAM-D providers, the plug-in providers, could tell the owners of the different devices, that is the developers of them, how they could fix their product. There was a development organization that presumably is us. We're developing the plugins. We're pretty flexible. We have control of the team's management and structure and development process. There is a technical environment. This is not flexible. There are a few tools available to help with the Palm operating system applications. And the architect's experience, well, that's not flexible. We can't suddenly change the architect. All right? So that's the context in which we're doing this. The functional requirements are listed there. They have 12 requirements, and I won't go through them other than to say, well, these are plugins that provide services to other applications. The non-functional requirements, there was a response requirement, should be activated within a certain time. Application shall receive a plugin within a certain amount of time. So the idea is that if an application is running and it requests a plugin and it doesn't have the plugin, it can request it across the network and the plugin will be downloaded or installed. There should not be a limitation on the number of plugins that can be installed, except by the limitation of memory. So it's not a software limit, it should be a hardware limit in some ways. And there are a couple of other requirements there. The quality attributes, usability rates pretty high. As you could imagine, these people with the PAM-D, Palm devices are not necessarily technically savvy. So they simply want to get an obvious message and give an obvious answer. Performance was pretty important. Availability, quite important, because these are user devices, and if they crash, then they better recover. And portability, very important as well. The architecture manager, architecture elements. We have a plugin manager that's manages all the storage of these plugins. As it records there, it coordinates communication with the plugins and the applications. It interacts with multiple applications and interacts with multiple plugins. Okay. The application must be PAM-D aware. It must be, must be plugin aware. So the application has to know that there is a plugin of a certain type, and obviously it has to know the interface to that plugin. So it's aware. Its functionality is to request a service from a plugin and to receive a service from a plugin. So it can request and receive. So it's got the rudimentary interchange. The plugins themselves, these are architectural elements. They conform to the PAMD specification, which we haven't decided on yet. Their functionality is to provide the service. Their functionality is to respond, receive a request from a plugin, provide a service to the application, and receive a service from a plugin. So plugins can call plugins. There is shared memory, mostly for data exchange, and there is a database in which the plugins are stored. Now, the architecture looks as you have it there. There is some memory in which the data is there. The application and the plugin act on that data. Not concerned about that, that's not a problem. What we have is the role of the plugin manager, in this case as pretty much a broker between the application and the plugin. In this particular architecture, all communication between the application and the plugin is via the plugin manager. Now, the nice things about this is that the application can't be caught out. It can't go and request a plugin that was there 5 minutes ago only to find it's been deleted, because if it was deleted, the plugin manager would know about it and could handle it gracefully. In the absence of that, the application itself has to handle the case of failure to find a plugin. So the architecture trade-off points in this one, this candidate architecture is good. It's good about availability, because the plugin manager will handle errors for applications and plugins. It improves the availability. Usability is improved because the application doesn't have to worry too much about error handling and therefore doesn't present an error to the user. Its performance is negatively affected, because there's always this interface, this change through between the plugin manager. All calls go through the plugin manager, so it slows performance down. Now we have it there. In this candidate architecture, all plugin calls are made through the plugin manager, so it does not allow the application to talk directly to the plugin itself. And as I said, this has the advantage that the application manager doesn't have to deal with weird things. It doesn't have to deal with the absence of a plugin or its sudden disappearance or other things like that. The PALM operating system is not that robust, so it couldn't gracefully handle faults. And the usability is improved. So that's the first candidate architecture. The second candidate architecture adds a bridge between the application and the plugin. It doesn't eliminate the manager, because if the application doesn't know of the plugin, it asks the manager, and the manager can locate it in its database, or I think it can locate it on the ether and get it downloaded. But once the application knows of the plugin and its existence, it then communicates directly with the plugin. So this particular architecture alternative, its availability, that is its reliability, is made worse, because the possibility is that the plugin got deleted when the application thought it was there. Now, I'm assuming with these devices the application lasts a long time, like weeks and months, and having initialized or having found a plugin and recorded that I should use this plugin in this circumstances is not for simply the session. It seems to stay there forever. So there may come a time when that plugin has gone missing and the application may not handle that circumstance that well. So availability can be impacted badly. Performance, improved. Okay, it's much faster to talk directly to the plugin than it is to go through the plugin manager each time. Usability, worse, because this problem, as I say, of if that thing fails, then suddenly the application has got to handle the errors, and the application is not geared to handling the errors, so presumably it will just crash and die. So the lack of transparent exception handling can negatively impact the availability of the system and decrease the usability. So that's, you could look at it and say, well, how likely is that, and how important is that, and decide whether your speed is more important than the usability and availability. Putting them two side by side, it looks like that. Candidate 2 has got better performance, but is worse in just about every other respect. So in summary then, in this case, we've taken a specific scenario, a specific element of the architecture, and that is the relationship between the application and the plugin, and concentrated on one specific scenario, which is that the plugin gets deleted. How do we handle things then? In one circumstance, with the plugin manager in the way, we handle it gracefully. In the other circumstance, when the communication is direct from the application to the plugin itself, it won't be handled gracefully. So they are the alternatives that we can envisage. Now, it's not our job as architects to decide which one is better. We have to present this back to the stakeholders and say, well, we can do it one of two ways. Which one do you like?